Which of these household items are affecting the VOC index in your home? On this episode of TechVentures, we will explore indoor air quality using a combination of temperature, humidity, volatile organic compounds, and pressure sensors from Sensirion and ST Microelectronics. Hi, welcome back to TechVentures. My name is Lazina, and I'm a technical marketing engineer at Future Electronics. If you're interested in checking out any previous episodes, then please feel free to click the link on the screen or check out the description box below. First of all, what is a VOC index and why is it important? So, the VOC index was conceptualized by Sensirion and is used to measure the concentration of volatile organic compounds found in the air. So VOCs are a group of chemicals that can easily evaporate into the air at room temperature. They are found in a variety of everyday products and industrial processes such as paints, cleaning supplies, varnishes, cosmetics, and fuels. The compounds that are found in these products can easily become gases that contribute to indoor and outdoor air pollution. The VOC index is important for assessing and managing indoor and outdoor air quality and potential health risks, as high levels of VOCs can contribute to indoor air pollution and are associated with various health issues such as respiratory problems and headaches. With the help of VOC sensors, we can take one step further to monitor and manage air quality in both indoor and outdoor environments. In today's episode, I'm going to show you how to get started with Sensirion's SenseEval SCB4X V1 evaluation board. It features a unique combination of a VOC sensor, a humidity and temperature sensor, as well as a barometric pressure sensor from ST Microelectronics. The combination of sensors found on this board allow it to serve both as a platform for evaluating the individual sensors and to prototype ideas using one or multiple of these sensors. The Sensirion board is compatible with ST Microelectronics' DIL24 socket and is supported by the ST Professional MEMS motherboard. The evaluation board can also be plugged into the X-Nucleo IKS4A1 sensor shield for the STM32 Nucleo ecosystem. Alright, let's get started. For today's tutorial, we will need a few things. On the hardware side, we'll need the Sensirion board, the ST Professional MEMS motherboard, and a micro USB data cable. And on the software side, we'll need the latest versions of STM32Cube programmer software and the Unico GUI, all of which are available for download on ST Microelectronics' website. To prepare the hardware, attach the Sensirion board through this connector here, making sure that the ST logos on both boards are in the same direction. First, we need to update the firmware on our motherboard. Make sure to download the latest firmware from ST's website. We need to enable DFU mode on our board. To do that, attach the MEMS board to the USB port and connect the other end of the wire to your PC. Press button 3 and button 2 together and release button 3 first, followed by button 2. LED 6 will light up and the device should appear in the Windows Device Manager as STM32 bootloader. Launch STM32Cube Programmer from the drop-down menu on the right. Select USB, and from the lower drop-down menu next to Port, your MEMS board should appear. Select Connect. Next, select the Open File tab, navigate to the location of your firmware update, and select the appropriate bin file. Make sure you select the full chip erase option. Next, select Download. Once you've received a Download Complete notification, select Disconnect. To exit DFU mode, press button 3. It will reset your board. Next, launch the Unico GUI. Select the Sensirion kit from the available options. You'll be greeted with a screen like so. To start measuring, navigate to the Options tab and click on Easy Configuration, and then on Start at the top of the Unico GUI. Select the two plot icons on the left-hand side of the menu. 4 plots will open up in a separate window. We can see the measurements for air quality, temperature, pressure, and humidity. I have a nail polish remover, a Sharpie, hand sanitizer, and a multi-purpose cleaner. Let's see which one of these items produces the highest VOC index. First up, let's try the nail polish. I can smell the fumes from a mile away, and I know it can't be good for indoor air quality. So I can see that the index reached a peak of 425 before falling down. Next up, we have nail polish remover. Again, a very pungent smell. I'm gonna guess it's gonna be the same as nail polish, if not less. Oh, the VOC index reached a peak of 453 before falling down. Next up, we have a Sharpie. Again, a very toxic smell. I'm gonna guess it's going to be more than the nail polish. Oh, I was mistaken. The VOC index reached a peak of 356 before falling down. Now let's see what the hand sanitizer has. It's pretty fragrant. It smells like lemons. Wow, I did not expect the VOC index to reach a peak of 500. That's more than the nail polish. I'm gonna turn my fan on, and as you can see, that helps bring the index down and clear the air. And finally, I have a multi-surface cleaner. And this one reached a peak of 110, which surprisingly is the lowest of all the items we tested today. On the VOC index scale, this offset is always mapped to the value of 100, making the readout as easy as possible. So a VOC index above 100 means that there are more VOCs compared to the average, while a VOC index below 100 means that there are fewer VOCs compared to the average. As expected, there are VOCs present in daily household items. Surprisingly, out of all the items we experimented today, my hand sanitizer is the one with the highest index reading. As the index is more intense than average, I need to ventilate my area. Well, there you have it. Now you know more about VOCs and how they affect indoor air quality. If you'd like more information, please feel free to visit your local Future Electronics representative or visit us online at futureelectronics.com. Thanks for watching, and I'll catch you next time on TechVentures with Lazina.